Alrighty, we are on chapter 4, lesson 2, graphing exponential decay functions. So we've done exponential growth functions and now we're doing decay. So the only difference here, the form is the same, but the letter B, the base, is a fraction less than 1 and it's a positive number. So it's between 0 and 1. Before we were working with numbers greater than 1, which is what caused growth. Alright, graphing them is very, very similar, almost the exact same. So we're making a table of values. Our x values are going to be -1, 0, and 1. Then we are plugging those into the equation. So y equals 1/2 to the power of x. So plug in -1, 0, and 1 into x. Alright, so we're getting our points. And we have the points -1, 2, 0, 1, and 1, 1/2. And then we're going to plot those. All right, remember the first one, 1/2 to the -1. The negative power flips your fraction, so that's why it's 2. All right, we still have that asymptote, the line that it doesn't touch, but it comes really close to. Draw a line through your points, and you're done. All right, repeat the same steps. Plug in -1, 0, and 1 for x into the equation to find our points. Again, the power being negative flips the fraction. For the first one, anything to the 0 power is 1, and then 1/5 to the first is 1/5. So we're going to plot those points. And again, these graphs look super similar to the growth, except they go down from left to right instead of up. Now your asymptote is at the x-axis. And then we draw the curve through our lines, or through our points. All right, the next ones are just a little different. They have that A number. So we're going to do PEMDAS and plug in the numbers for x and do the exponent first and then deal with that 2 out front. So 2 times 4, since 1/4 to the -1 is 4. All right, and for this one, it's 1/4 to the power of 0, which is 1, but then you multiply it by 2 to get 2. So just make sure you're doing things in the right order and you don't forget about that 2. And then when you're multiplying fractions, you can do that little dodgeball method that we've talked about in class, or use a calculator. Either way. Again, I'm just going to plug in or plot these points on the graph. Draw my asymptote, which is just a dotted line. And then whenever I draw my line through, I know it should get really, really close to that asymptote, but not technically touch it, even though it looks like it is in that picture. All right, this next one, the graph is going to look slightly different, but we are not going to do anything different in our steps. So plug in -1, 0, and 1 for your x. -1 flips that fraction to be 5/2. And then when you multiply, you go straight across. So -3 times 5, and -3 is the same as -3/1. So 1 times 2 is 2. And then -15/2 is a hard number to graph, so I recommend putting it in a decimal form to be -7.5. All right, working out the rest of them. So -6/5 is the same as -1.2. And when you're graphing those fractions, like -1.2 needs to be closer to -1 than it is -2, but it's not super specific, so don't worry about it too much. All right, and then we're going to plot those. So at -1, we're at -7.5. We're usually above the x-axis, but this time we're below, and it's just a reflection of what we're used to seeing, but our asymptote stays the same. And you still get really close to that line, but don't touch it. You just graph through the points, but that -3 is what has made it flip over. Alright, the transformations have not changed from 4.1. Right, the x minus h moves the graph. If it's x minus h, then it's to the right, and if it's x plus h, it's to the left. And then k, if it is plus k, it goes up, and if it is minus k, then it goes down. Same rules as before. So we first start by graphing y equals 3 times 1/2 to the power of x, and then we will deal with the +1 and the -2 afterwards. So go ahead and make a table of values. Our x values are -1, 0, and 1. And then our y values, when we plug those in, are as follows. Right, I am going to go ahead and plot those points that I have found in this dark tealy blue color. And then when I shift them, that's the final graph, and I'm going to use a bright green color to do that. Alright, so now looking at the formula or the equation, I have x plus 1 in my exponent, and following those rules above, that means that I'm going left 1 unit, and then the -2 means I go down 2. So I take every point and I go left 1 unit and down 2 and plot a new point. And don't forget about the asymptote. Whenever you move that, it needs to go down 2 as well, and I forgot about that. I graphed in a funny order. Sorry about that. But remember to move your asymptote as well. It doesn't really matter if it goes left or right because it's a line that continues on forever, but it does shift up or down. And that's your new graph. Now this also says state the domain and range. The domain is still going to be all real numbers. And the range, it looks like I have y values from -2 up. So my range is y is greater than -2. Right? It's greater than that asymptote. Again, for letter B, I am going to start by just finding the values for 2 times 1/3 to the power of x and graphing that before I shift it. Okie doke, plotting those points, plotting -1, 6, 0, 2, and 1, 2/3. Again, don't be too particular about the fractions and the decimals. Again, graphing in a funky order. Ignore me. Alright, now doing the shifting, I am going right 2 units and up 1. So I take every point and I go right 2, up 1, right 2, up 1, right 2, up 1. And then my asymptote needs to move up 1 as well. And then I draw a line through my points. Sorry for the funny order of drawing a little bit of the line and then the asymptote and then the other line. Do however you would like. Alright, the domain again is all real numbers because the graph is going to stretch both directions for the x. And then from the asymptote at 1 up, So y is greater than 1 for the range. Alright, exponential decay models are similar to the exponential growth models, but now we're going down. Alright, so we have this formula y equals a times 1 minus r to the power of t, and a is our initial amount, and r is now the percent decrease instead of increase. Alright, number 1, a new car costs $25,000. The value of the car decreases by 15% each year. So filling in for this formula, my initial amount is $25,000. My percent decrease is 15%, which remember as a decimal is 0.15. And then to the power of t. I can simplify this by already subtracting the 0.15 from 1, which is 0.85 to the power of t. So that's my model. For letter B, I am going to plug in 4 for t because it says estimate the value after 4 years. And our time, which is why it's t, is 4. I'm going to need to plug that into a calculator, and you end up with $13,050 and 16 cents. So when we're talking about money, round to the hundredth place. Alright, so having a car for 4 years decreases the value a whole lot. Just think about that when you're buying a car. Alright, a new boat costs $4,200. It decreases by 10% each year. So the model looks like that. And to simplify, it's y equals 4,200 times 0.90 to the power of t. And now for letter B, we're estimating the value of the boat after 6 years. So plug in a 6 for t and plug that into your calculator. So 4,200 times 90 to the power of 6. And if you're not sure how to plug that into your calculator, I would do 0.90 to the power of 6 and then multiply by 4,200, okay? Because your calculator doesn't know order of operations like you do. Alright, this next one. The value of a motorcycle has been decreasing by 7% each year since it was new. After 3 years, the cost of the motorcycle is $3,000. Find the original cost. So find the initial amount. So this time we have to solve. It's a little different from the one before, and there is one like this on the worksheet. So I know that after 3 years, the value is 3,000. So that's going to be my y. So 3,000 equals a. I don't know what it originally cost. And then I do know the 7% decrease in the 3 years. So I can plug those values in for r and t. So now I have 3,000 equals a times 0.93 to the power of 3. Okay. In your calculator, you need to figure out what 0.93 to the third is. And that is 0.084357. And so to find a, I need to divide by that number on both sides. And this should give me my initial amount. When you get this number, it should be larger than the amount after 3 years because it's depreciating in value. So when you bought it, it should cost more than it does 3 years later. So I end up with $3,729.69.